Hello everybody, today we're going to look at this set of simultaneous equations. X plus y equals 1 and x times y is 1. So the sum of two numbers is equal to its product and they're both equal to 1. Now I've seen this problem before on YouTube, and a lot of the time the instructor will try to talk about substitution and using the quadratic equation. We are not going to be using the quadratic formula at all. I'm going to show you how to do this using some much more fundamental properties of numbers that gives you a lot more intuition for similar problems. So one of the very first things that we want to do with these kind of equations is we want to try and work out the nature of the solutions. So let's have a look at the product. Generally when things are written in products we get more information, it's more limiting. We've got two numbers multiplied together to make one. So if they are real numbers, what this means is that either both positive, because the positive times the positive would of course be positive, or they're both negative. All right? They can't be mixed if they are reals. But now let's have a look at their sum. They have a positive sum. So that means that if they are real numbers, then they must both be positive. So that really narrows it down. So that's one of the things that we can do is we can say x and y are both greater than 0. Now, the second thing I'm going to do is I'm going to substitute in y in terms of x. So this equation here turns into y equals 1 over x, and I can substitute that into this one. And this gets us another equation. So you get x plus 1 over x equals 1. Now this is quite an interesting equation, and I don't have time to go into this in full. But one of the things we can do, because we know that x times y equals 1, then we know that if they are real numbers, then one of them must be greater than 1, or one of them must be equal to 1, or they must both be the same as 1. You can work that out yourself. So because they're interchangeable, we know that we can just always say that x is going to be the one that's bigger than 1. Now this is quite interesting, because if we take a number that's bigger than 1, okay, let's just take 1.01, and then we add 1 divided by that, we are clearly going to get something that is bigger than 1, which means it's not possible. So we've established that if it's a real number, they both have to be positive, but if they're also real numbers, then one of them must be bigger than 1. But if one of them is bigger than 1, then it can't work, which means they can't be real numbers. So if they can't be real numbers, why don't we make an assumption that perhaps they are complex? So if we assume that they're complex, this means that x is going to be a plus bi, and y is going to be c plus di. So it looks like there's 4 unknowns to work out here. However, by looking at the equations themselves, we can quickly narrow this down. So let's have a look at the first thing. The first thing is that x plus y equals 1. So what does this tell us? Well, 1 is a real number. So what it means is that the two imaginary parts of x and y, these things here, must in fact be negatives of each other. So now we know that x must be a plus bi and y must be c minus bi. That's the first thing. Now we also know that their product is 1. Now if two numbers have a real product and their imaginary parts are both the opposite of each other, that means they must be complex conjugates. So this means that x must be a plus bi and y must be a minus bi. Now we still don't know what a and b are, but we've simplified this tremendously. We've gone from having 4 unknowns to 2 unknowns. This is definitely going on the right track. Now this is really simple. We can just substitute in. So we're going to substitute in for a and b. For x and y. So we get a plus bi plus a minus bi equals 1. Well, of course, the imaginary parts will cancel and we'll end up with 2a equals 1. If 2a equals 1, a is a half. Alright? Now, because they're both conjugates and they both multiply to make 1, you know that the original size, the magnitude of this complex number must be 1. And because we know one side of it now, we can just draw it out like a right angled triangle So we've got a half here, and then we've got the imaginary part b, and then we know this is 1. Well, this is just Pythagoras' theorem, so you have a half squared plus b squared equals 1 squared, so you get a quarter plus b squared equals 1. And therefore, when you rearrange this, you get b equals root 3 over 2. So to check that it works, let's do x, which is a half plus root 3 over 2i, plus a half minus root 3 over 2i. Well, what does that equal? 1. Now let's do the product of these two numbers. So we're going to do this. Let's just copy that, and then we're going to copy it again. I love good notes. Change that to a negative, and we're off to go. Now this is just simply an expansion of the difference of two squares, so you can use a bit of a shortcut. You just need to do that and then that term, because the others will cancel. So what are we going to get? We're going to get half times a half, which is a quarter, and then we're going to get positive, because you get negative and a negative, and the I squared, positive root 3 over 2 squared, root 3 over 2 squared, which is just a quarter plus 3/4 equals 1. There you go, done. And no need to invoke the quadratic formula, and you learn a lot about how to think about complex numbers and about how their conjugates relate to the roots of symmetric equations. If you found this helpful or interesting, please hit the like button, let me know your thoughts in the comments below, and of course subscribe so you won't miss the next video.